Our last speaker for this session is Mr. Arvind Vasu, Senior Vice President of ABB Ventures. Ladies and gentlemen, please welcome on stage Mr. Arvind Vasu.
Hello, good afternoon. I have some good news and some bad news. The good news is that this session will be very brief and concise. Unfortunately, my colleague who is the CTO of ABB India couldn't make it to this talk. This was actually his slot. He is stuck in Bombay in other meetings with our CEO and some key customers, and couldn't make it back to Bangalore. But you've got me, and he's asked me to deliver some of his messages about digitization and Industry 4.0. So I'm going to try and give you a picture of what is ground reality today in process automation and robotics without trying to fly too much off the ground. But I'm going to stay pretty grounded to give you a picture of what is available today and what are the trends that we're seeing coming. Industry 4.0 and digitization in general is something that's relatively new to the industry. We're still in the infancy of the stage of digitization. So there's enormous potential ahead of us in being able to utilize the different technologies that are available. In my current role, I work with ABB Technology Ventures, which is the corporate venture capital arm of the group. So we're seeing a lot of technologies out there, including AI and machine learning and industrial IoT and all kinds of things. But let's look at what's available today. So what is Industry 4.0? We started with the first practical example, which was the steam engine in 1700s, and then in the late 1800s, we saw conveyor belts and production lines, and then we saw more software-based and electronics-based control systems, which came in the 60s and the 70s. And we've been through all that as well as all our competitors and colleagues in other similar companies have been delivering this around the world to our customers. So the world today is moving towards Industry 4.0, and what it's all about is, of course, the Internet of Things. The Internet has changed this, the potential of what you can do in terms of the availability of data, big data, which you can analyze and use to predict stuff or improve productivity and various things. And the computing power that you have in the palm of your hand, the devices that have become smaller, that have shrunk, and are more affordable and available today to be plugged into an industrial process. It's really not just the Internet of Things, but we'd like to say that it's the Internet of Things, Services, and People. And this combination is what is really going to drive and give value to customers. So let's take a look at what that means in reality. If we take a simple asset or device like a motor that's working in a plant, the conventional way of getting the best performance out of that motor would be to find information about it. And how did you find information about it? In the age before the 60s was, and certainly 60s and 70s, you had product manuals, you had technical data sheets, you had things on paper and in files stored away. So it took a lot of time to sort through that information. Digitization started, I would say, in the 90s, where you had we have been playing with information technology since then, and we had digitized a lot of that paperwork, and we had manuals that are available in soft form. We had design documents and drawings and such available. Today, there are sensors that you can slap onto these devices. So, for example, smart sensors that don't require any wiring at all, and these are sensors that can sense multiple things. They can sense vibration, they can sense position, they can sense tilt angle, they can sense temperature, pressure, etc., etc. And through them, you can also read not only those data, but you can also read electrical data. And you can take that information, send it to a cloud, and analyze it and predict the failure of a certain component, predict how to improve the productivity by tweaking the performance of that asset. So that's what we're seeing. So yeah, I basically talked about combining the data from individual assets out there with other computing systems. So the industrial IoT gives you the ability to also take data from other sources, weather data, and financial data, for example, and positioning data to bring out new information, combining those data to look at things like how to reduce downtime, how to extend the lifetime of a product, and increase efficiency in manufacturing plants. We always had some kind of, and even though it was not called the Internet of Things, if you look at this drawing, it represents a process automation engineer's world. Even if you go back 30, 40 years ago, where you have on the upper level you have different systems or operator interfaces, engineering interfaces, where you can view data. Different people from having different roles in the organization could view data and control the process or design the process. Then you had a network which was probably TCP/IP or a bus system like Profibus or DeviceNet, and then you connected different controls. So this was kind of an intranet of things. It wasn't connected to the internet. Our customers weren't quite ready to do that, neither were we. But in the late 90s, we did attempt, some of us in the industry did attempt to plug in data from other systems, from ERP systems, from maintenance systems, and combine that data to improve productivity, especially in terms of maintenance. So this world today is changing, and we are able to view and analyze data not only from the old Internet of Things, but we are also able to connect it to the Internet. We're able to analyze specific data in the cloud. We're able to take data from specific devices in our production lines and do predictive maintenance, to productivity improvements, and all the things that we mentioned earlier. So some of the benefits that we're seeing that are already coming out of using these technologies are productivity increases, of course, saving energy, increasing quality, improving the lifetime of assets and maintaining assets, more reliability, safety for the people working in the plants, and better environmental protection and security. We need security now because, I mean, it's a big risk if someone hacks in and would set fire to a power plant or destroy a cement plant. That's actually possible. And the interfaces that we have in terms of modems and other things are quite old-fashioned today, and those have to be replaced in order to improve the security so that they can't be hacked and causing serious damage to both human beings and to assets. Another aspect of industrialization we have two types of automation. If you look at what ABB has been going through, we have the continuous processes, which we just talked about, where we would apply that kind of automation system to a cement plant or chemical plant or a metal rolling mill or a refinery. But when it comes to discrete automation, when you're manufacturing products like automotive parts or automobiles, you see a different kind of automation using robots that are moving material, physical material in a production line, and probably not continuous. There could be a mix of both automatic and manual stations. Today, if you look at yesterday in terms of robotics, the industrial robot was a monster of a beast, and I've had the opportunity of working with robotics, building our robotics business in India. So you needed to cage those animals. Safety was a big concern, and you had to have safety nets, you had to have light curtains, you had to prevent the machine from working or make it stop working if somebody went into the working envelope of that robot, because they moved at tremendous speeds. They still do. They're still made of metal largely. So if they hit somebody, that could be fatal. The kind of robots we're seeing today are more what you call this is Yumi, one of our later models. It's a two-armed robot which resembles, the industrial robot has always resembled a human arm, and we've been doing robotics since 1974. Today's robot has soft plastics, has more sensors on it that can detect the presence of a human and slow down its movement, and it's very sensitive to touch. So it's called Yumi because it's short for you and me. It's designed to work with human beings, together with human beings on a production line. So in fact, on one side of the workbench could be a human being, and on the other side is the robot working in collaboration. The robot has cameras, it has flexible hands, it has soft plastics, it does not need a cage anymore, and it's designed to be more human friendly. The way we are working with robots and programming the robots is also changing. We're using more of virtual reality. We're using virtual reality and augmented reality in the industry, not only for programming, but also for troubleshooting, for helping engineers who are on site to look for problems, where they could be talking with someone at your service headquarters that is actually sending them digital information which they can see on their virtual reality glasses or augmented reality glasses, and can guide them. So you don't have to have the real top experts in the field anymore. When you're commissioning the plant, or where you're installing something, or whether you're servicing equipment. The robots that we've been working since 2004, 2005 almost with something called remote service. We didn't know that it was called the Internet of Things in those days. We just called it remote service. What we did was put a 3G communication hub into the robot controller, and with a SIM card you could communicate with that controller. You could download data. You could get data sent to one of the service centers around the world. And actually in Bangalore, We do this service for over 8,000, 10,000 robots around the world. And using the data, we didn't know what to do with the data in the beginning. But then when you have things like AI and machine learning were just at their infancy, but we started comparing the data from different data sources inside the controller. You could look at temperature, you could look at the production data, and you could correlate things. So you could tell that if the temperature of the controller was increasing, probably the cooling fan on the controller had failed. So remote service has been a reality for us for over 15 years almost. We talked about virtual reality, and the other part about virtual reality is also the way you program robots that has changed. In the beginning, you had to write code. You had to write code in something that resembled the C language. You could use a simulation tool or a virtual reality tool like Robot Studio, which was a piece of software that you used on a laptop or a desktop to program the robot in a 3D environment. But then the engineers still had to have quite a lot of concepts in their head. They need to understand 3D spaces and be able to write X, Y, Z in their head, or imagine that in their head to be able to do that. Today we teach robots by, of course you could teach a robot with a joystick by moving the robot arm to the place where it had to start its, let's say, pick up an object and place it somewhere else, and you could define those 2 points and program it to run in between those, and maybe apply to close the gripper or open the gripper to pick up and release an object. Today you can actually catch hold of the robot arm instead, and you have a jogging mode where you could just pull it to where you want it. And what we're seeing that would be the next step is using virtual reality, using AR and VR glasses. Could be one way, which we're already experimenting with, where you can have a VR glass and then use your finger to hold the robot manipulator and move it, and the robot will move. And you can translate that to the simulation program or directly to the robot controller. But tomorrow, the robots will actually learn from watching us. So if we have cameras, and we probably will also have voice commands using something similar to an Amazon Alexa or Google function, where you can talk to the robot and say, hey robot, move here or move there, and they could be watching us moving our hand to a certain position, and the robot will mimic what the worker who's working on the line does. So those are some of the trends which we're seeing in the not too distant future, and I hope this presentation gives you some kind of idea of what the industry and the automation business is going through. So I'd like to thank you for giving me the time to talk on behalf of Dr. Rahman. If you have any questions, I'm happy to take one or two now. Anyone?
Mike.
Okay, thank you very much.
We'd like to thank Arvind Vasu for that last session. I'd like to request all of you to please give all our 4 speakers a big round of applause. I'd like to request Mr. Anil Kumar, Chairman IESA, to present a small token of our appreciation to Avnish Agarwal. I'd like to request him to please come up on stage. It was the second last session for this first day of the summit on game changers, mega trends that will rock the world. We'd like to thank our first speaker, Avnish Agarwal. I'd like to request the Chairman IESA to also present a small token of our appreciation to our second speaker for this session, Mr. Rohit Kapoor. Thank you very much indeed. I'd like to request Mr. Ashok Mishra, IESA Executive Council member, to please present a small token of our appreciation to Sundara R. Nagalingam. I'd like to request Mr. Rahul from IESA to present a small token of our appreciation to our third speaker for this session, Mr. Sundara R. Nagalingam. Ladies and gentlemen, please give him a big round of applause as we thank him for that very informative session. And last but not least, I'd like to request Mr. Rahul to present a small token of our appreciation to Mr. Arvind Vasu, Senior VP of ABB Ventures, our last speaker for that session.